Hello everyone, I'm Sandeep and today I'm presenting you our submission for the assignment designing a community application for stream processing analytics. This is a high level design of the application. It consists of these tiers: front-end clients, API or the load balancer tier, microservices tier, the database or the analytics tiers. So the first tier, front-end or client, will have the four possible access points through which users can access the application, which are web UI, app view, client facing API, and the messenger application. Then the second tier is the API and load balancer tier. It consists of the API gateway, which will aggregate the APIs from the microservices tier based on the function or the protocol which is exposed by the API. These API gateways can be a combination of Nginx, Musket Broker, and the WebSockets API. Nginx will be basically used for the REST APIs, exposing all the basic HTTP operations which we could do: get, post, put, and Musket Broker can be used for streaming incoming messages coming in from user logs, user chats, maintenance logs. Then WebSockets will power the Messenger application and will be used for incoming messages, delivering messages, notifications, etc. In the microservices tier, it will be all based on Kubernetes clusters. These clusters will host service groups, hosting parts of services, which includes front end in form of Django, uh, and backend in form of Django REST. We choose them because that suits our needs and requirements for this kind of application. Then the static content, we would like to host it using Apache server, that also through microservices service group. Then we would like a service group of Jupyter, Python, Apache Spark stack that will power our analytics and data science section of this application. Then the next tier is database and analytics tier. The first data stream which we will have will be the app and the user info tables. This will form the basic foundation of the application and will contain all information about scaling and service of the application, and user records, the user definitions, regulatory information. This will be stored in RDBMS type PostgreSQL server, and any media, anything which is required in user definitions or user uh, profile will go to the blob storage. The next stream which we have here is user posted content. As more and more users sign up, this database section will grow, which we have used Cassandra and blob storage to power. All text and small blobs will be stored in Cassandra directly. Any big blob will be stored in blob storage along with the pointer and other metadata and related information in Cassandra. Then the third stream which we have will be real-time messaging and user session information, which we have tried to solve using Redis cache, and all the real-time messages will go in Redis cache reflected back to other users or groups based on the destination: one to many, one to one, direct messages, what are they, what kind of messages user wants to send, and the user session information. This will also power the uh, microservice which will form and which will be exposed as an API to other services or API gateway for uh, authentication or user session. So This Redis cache will also archive the information and make it persistent on Cassandra. All the real-time messages and user session information will be made persistent to the to a Cassandra database. And then let's talk about the other sections which we see here, such as search and indexing thing. So this will actually let the users discover more and more content based on their query, and this will pull in data from the user information or the user posted content, index it, and make it available for user searches. Next thing which we see here is a recommendation system, which will pull in data from the user posted content and index it in a graph. Then using collaborative filtering or ML, we could actually cluster those graphs and make a user feed available, a rich user feed which a user can relate to. Then last thing which we see here is analytics and the data science section, which is powered by Kafka on the backend, which is again pulling in real-time data from Redis and archive data from Cassandra based on what kind of analysis which we do. The actual drivers of this section will be the Jupyter, Python, and Apache Spark stack, which will have it available in the microservices. And we could actually perform any kind of analysis or a predefined analysis which can be run as a cron job and made available to users. That's all we had for high level design. Then let's see each individual tier. The first one is the front end and the client tier. As I have explained, again, this will have all the four supported access points for users with respect to the application: the web UI, application view, messenger, and client facing API. Then we have the API and the load balancer tier. It will combine all the microservices to multiple APIs based on their protocol and function. It will also act as a firewall to protect any unauthorized access to the system. Then we have the microservices tier. It will form the basic foundation, or it is the business logic of the application. Every interaction to the application goes through those microservices. These microservices will talk to each other or to the incoming request from the API gateway, authenticate each request using a different microservice which will be dedicated for authentication. It will read the or maintain the user session information and make the system secure. Uh, for frontend we are using Django, for backend we are using Django REST, for static we are using Apache Server. It will be all based on Kubernetes cluster. It will contain both async and sync microservices based on the type of request or requirement which comes in. Uh, each These are all this is all horizontally scalable. More pods or more instances will help scale the microservice tier, and for that, for communication, a service bus is deployed. A microservice will be dedicated for managing and scaling the application. It will try to check the idle time of each and every microservice and try to scale them down or scale them up based on the requirement. It will manage any. It will also manage any service group which is facing difficulties, or if there is any anomaly, uh, it will try to detect that. Then let's talk about the database tier. So we have three type of data streams here: app and user info table, structured data, which will be structured data, user posted content, which will be structured and unstructured data, both real-time messages or user session information, which can again be structured and unstructured data. App and user info table, this will be the basic foundation of the application: app definition, user information, regulatory data, We'll try to create the tables directly, and some tables will be created by Django models. This database will be eventually small, but will build up as more and more users sign up. This kind of data streams require the data is not frequent, but consistency is a requirement. So we went ahead with PostgreSQL, which is an ideal choice for such requirement. So uh, we have tried to define a few tables which we try to create, such as there is a master table which will contain these columns, which will define the user, then user groups, then details about the user groups, then some definition about the application, the status of the application, such as the service groups which are there in the microservices. This table will be used by the microservices to scale, like the management, like the service will use it to scale up and scale down the application and store the current status of the application. Then the second data stream which we have is the user posted contents. This kind of data, such as posts, comments, likes, messages, it can contain text, media, anything, and there'll be a lot of those coming in as users increase. So it has all three essence of big data: high velocity, high volume, high variety. The media files can be large enough, so high volume. They're high velocity because a lot of users are there. High variety because we don't know what's coming. Media can be anything, or we have text, media, messages, anything. So here the data is accessed frequently, inserted frequently, but not all those upload or post messages do edit them. So we require a system which is highly available, highly reliable, but immediate consistency is not required. So if I post something, it can be made available after a few seconds, or 1 second, 2 seconds, something like that. So for text and small blobs, you can use Cassandra. It's an ideal choice. It has Okay. We can talk about Cassandra in the same slide. All the big media files can go into blob storage. Pointer can be stored in Cassandra. Why Cassandra? Because it's NoSQL, provides flexibility for complicated user activity. We can store it easily. This is highly available. Uh, Replicates the data, so it's highly reliable also. Then the data, it's not immediately consistent, but it will be eventually consistent. So it's an ideal choice. We try to create the schema or structure, even though we can show non-structured data here. So, but still something which defines what all can have in a post. So this is the table explaining or defining a post. Then a share can be, you can share a post, so share. Then messages, this is interesting. Cassandra will only store the archive messages. The real-time messages will be there in Redis. Once a particular threshold is passed, they are stale, we can store them in message archive instead of storing them in Redis, so they will be archived here and retrieved when required. Then the third data stream here, real-time messaging, user session information. All the incoming messages and user session information is stored in Redis cache. Eventually, it will be persistent in Cassandra. So if you want to do any analytics or archive retrieval, you can do it from there. So this will be talking to the microservice, which will be further exposed as WebSockets, and messages sent can be one to one, one to many. Will be all delivered using WebSockets. You can share blobs that will be delegated again to the user posted content microservice, but a pointer there will be stored and transmitted back through WebSockets to the destination, and there the UI knows what to do with the pointer and can restore back the rich content using the REST or the HTTP protocol there. We try to document how a message can look, and the master table defines that. Then recommendation system. For generating user feed, we need to know what a user sees, what he likes to see. So an ideal thing is a graph database. We don't directly ingest anything into graph database, but we can pull the information from Cassandra uh, time to time, and we can index it using relationship topology. We can curate content, connection groups, recommendation based on the user interest. It will actually create a user feed for the user. Then search, as we have talked already about it, Elasticsearch, we will fetch pulling data from Cassandra and PostgreSQL, index it, make it available for the users. So a search query can be performed to find posts, users, new connection, anything based on the user's query. The analytics section. So we see that we can do two types of analytics: predefined insights, which can be generated by cron jobs using ASIC microservices, and custom analysis, which can be done by a user using the Jupyter interface. Can internally use Python, Spark to perform analysis on the data, pulling in by Cassandra, by Kafka from Cassandra and Redis. Again, Cassandra contains the archive data, and Redis contains the real-time data. So we could do both kind of analysis. We can do data, we can do predictive analysis, or we can do data exploratory analysis. We can try to see what went wrong, all those kind of analysis. Thanks. That's it.